Chapter 2.2, Basic Differentiation, Rules, and Rates of Change. The constant rule is that the derivative of a constant function is 0. That is, if c is a real number. Then d over dx c equals 0. The power rule. If n is a rational number, then the function of f of x equals x of n is differentiable, and d over dx of x to the n equals nx to the n minus 1. For f to be differentiable at x equals 0, n must be a number such that x to the power of n minus 1 is defined on an interval containing 0. The constant multiple rule. If f is a differentiable function and c is a real number, then cf is also differentiable, and d over dx of cf of x equals cf prime of x. The sum and the difference rules. The sum or difference of two differentiable functions of f and g is itself differentiable. Moreover, the derivative of f plus g or f minus g is the sum or difference of the derivatives of f and g. For the sum rule, it's d over dx of f of x plus g of x equals to f prime of x plus g prime of x. The difference rule is d over dx of f of x minus g of x equals f prime of x minus g prime of x. Oh, sorry, I don't know if that was in camera. There you go. The derivatives of sine and cosine. For sine, it is d over dx of sine x equals to cosine x. For cosine, it's d over dx cosine of x equals to negative sine x. To find the slope of a graph at any given point on x equals c. Step 1, take the derivative at any point. Step 2, clearly write f prime of x equals. Evaluate f prime of x at x equals c. Finally, write m equals f prime of c, or the slope equals. Finding the equation of a line at a point at x equals c. Step 1, find the slope at x equals c above x equals c. Step 2, evaluate f of c. Step 3, use the point slope equation, y minus f of c equals to f prime of c multiplied by x minus c. Finally, just solve for y. So right here, this is basically saying like the function, just like f of x, this is s of t, and it's the rate of change, which is kind of like physics, or it is physics. The average velocity is changing position over time. That's where we get the s from, it's where we get the t from. Now, one thing to remember is that your velocity function is the derivative of your position function. So this is a position function. This is a common one that we use in physics all the time. Let's find the derivative of it. So we'll start by s prime of t equals to 2 multiplied by 1/2 g multiplied by t plus v. Okay, the 2 cancels out the 1/2, so we'll go ahead and cross that out right there. And then so this just becomes g multiplied by t, so we'll go down s prime of t equals gt plus v. And the velocity can be represented. I would like to apologize for that. As I was saying, velocity can be represented by this function that we got by finding the derivative of this position function.